At the end of the 1990s, the United States, the European Union, and other countries initiated an international effort to discover and study near-Earth objects, NEOs. Known by their English acronym, NEOs are minor bodies in the solar system whose orbits can bring them close to our home. Small objects made of ice and rock formed in the cold and dark outskirts of the Mother Star's empire that, by a whim of inevitable gravity, could pose a threat to the oasis of life on our world. The so-called SpaceGuard survey was conceived to catalog all those NEOs with the potential to cause a global catastrophe. And even though, in 2011, the US Congress announced that over 32,000 asteroids and comets entering our gravitational realm had already been detailed, efforts continued. We had to scan the skies to safeguard the future of our world. Therefore, as part of a project funded by NASA, the Pan-STARRS telescopes at the Hawaii Observatory joined this research. Leading in astrometry and photometry, they were perfect for detecting fast-moving bodies navigating close to us. And on the morning of October 19, 2017, on that volcano summit, something strange emerged from the skies. Astronomers at the Haleakala Observatory detected something unusual in the telescope images. They had captured an object hitherto unknown, not catalogued in any database. Something had traversed that portion of the sky like a cosmic missile, so fast that it had been imprinted as a blurry grey line. They had a new candidate, a mysterious body that might pose a threat to Earth. And although they knew nothing else about it, the estimate of its speed, 160,000 kilometers per hour, was enough to understand that a hypothetical impact would generate energy equivalent to a nuclear bomb. Fortunately, by detailing its trajectory, all those concerns were alleviated. They had caught it when it was already moving away from us. And although at its closest approach, it had come within 18 million kilometers, it was already heading towards the depths of the solar system. However, at that moment, they saw strange things in that trajectory. The orbit didn't seem circular. It was as if it wasn't gravitationally anchored to the sun. There were unprecedented things in it, things they had never seen on any other object in the solar system. Everything sailing in the realm of the sun follows a closed orbit around it. Larger bodies, the planets, draw practically circular paths. Smaller ones like comets and asteroids trace a wider route with markedly elliptical orbits that take them to the outskirts of the empire before returning to its heart. But these eccentricities always have to be less than 1. Anything outside that range would imply that the body is not orbiting anything. A scenario hitherto hypothetical where it is not anchored to the gravity of any star, simply diverted by its influence while drifting through space. And against all odds, when a few hours later, and with the help of the ESA, the results arrived, they saw that the eccentricity of that strange body was 1.2. It was off the scale. Furthermore, they had calculated its speed at 87.7 kilometers per second. In the region where they had seen it, within the orbit of Mercury, the escape velocity from the sun's gravity was just over 80 kilometers per second. Its orbit was telling us that it wasn't following a path around the sun, and its speed indicated that it could escape its gravitational power. Everything was leading to the same place. They hadn't found a body falling from the far reaches of the solar realm. It wasn't orbiting the sun. Whatever it was, they were in the presence of the offspring of another star. A visitor from another stellar system that, after crossing the oceans of space darkness, had entered our home. They were well aware of what they had in their hands. The first interstellar visitor. An entity that, before continuing its eternal journey through the seas between the stars, had immersed itself in the island of the sun. Baptized as Oumuamua, the evocative Hawaiian name for the messenger from afar that arrives first, it was the first body conceived under the light of another star to cross our path.
Oumuamua era el primer cuerpo procedente de otro sistema estelar que nos visitaba, pero teniendo en cuenta su velocidad solo tenían 3 semanas para estudiarlo, antes de que desapareciera del alcance de nuestros telescopios y se desvaneciera en la oscuridad. Estaban en una carrera contrarreloj.
Aware of the magnitude of the discovery and above all, that time was running out. Astronomers at the Hawaii Observatory contacted teams from the world's leading astronomical research centers, requesting that all possible telescopes turn their gaze toward this body that, in a matter of days, would be lost forever. Oumuamua, in just a few hours, had become the top priority of the community. It was perhaps a unique opportunity to reveal the secrets of the offspring of another star. The race against time had begun. From the very beginning, it was clear that there were 2 main candidates to explain its nature. Oumuamua had to be either an asteroid, a rocky body formed near a primitive star system, or on the contrary, a comet, a relic of ice and rock from the cold outskirts of a star's empire. Asteroids and comets are usually expelled from forming star systems due to gravitational disturbances in the chaotic era following the birth of their sun. It made sense then that Oumuamua was a body banished from its realm, expelled by its star and condemned to wander in darkness until millions of years later, the sun and we crossed its path. Unfortunately, there are no telescopes powerful enough to directly determine the size and shape of a body less than 1 kilometer in diameter at such a distance. Therefore, to unravel its nature, an alternative path had to be taken. 2 days after its discovery, the Gemini Observatory North, located on the Hawaiian volcano Mauna Kea, began the exploration of Oumuamua. With its optical infrared telescope, they inspected the body knowing that there was only one thing that could give them the answers. Everything rested on the light, on how that body reflects the fire of the sun.
Si un cuerpo sobre el que incide la luz solar es perfectamente esférico, su brillo se mantendrá estable a medida que gira libremente por el espacio. No importa desde dónde lo mires, siempre reflejará la misma cantidad de luz, pero todo lo que no sea una esfera perfecta tendrá cambios periódicos en su luminosidad. Dependiendo de dónde lo mires, estará reflejando más o menos luz, una propiedad que los astrónomos pueden usar para estimar y reconstruir la forma del cuerpo.
But when the results of photometry were obtained, they began to see strange things. Oumuamua was rotating every 8 hours, showing the largest perceived brightness variation ever seen in a celestial body. The brightness fluctuations were incredibly pronounced, and there was only one explanation. It had to be an elongated object, but at that moment they were not aware of how extreme it was. After a thorough analysis of the light fluctuations, it was determined that the ratio between length and width could be 7:1. There was no precedent. Oumuamua measured about 230 meters long and barely 35 meters wide. A shape that, in a universe where gravity tends towards sphericity, had never been observed. The mystery surrounding this entity had multiplied, just like the difficulties in unraveling the nature of something they couldn't compare to anything. The first hypothesis they considered was that Oumuamua was a comet. Icy relics that roam the outskirts of star systems, and therefore are the bodies most easily banished. Perhaps, tens of millions of years ago, it had started its journey as a relatively spherical body. But after that endless journey through interstellar space, victim of cosmic dust and micrometeoroids bombardment, its ice would have eroded. Oumuamua would have become thinner and thinner until it turned into the comet that entered our realm. The theory made sense but collapsed in a fundamental aspect. If it was indeed a comet, having passed as close to the sun as they knew it did, it would have heated enough for the nucleus to sublimate. The ice should have turned into gas, forming an atmosphere around it that, due to the star's energy, would have ionized, generating its own light and creating the famous tail of a comet. But there was no trace of it. No telescope in the world had captured the trail of that tail. Oumuamua could not be a comet. And with that icy nature ruled out, they only had one option. It had to be an asteroid. Assuming it was a solid mass of rock, another different process had to carve its strange shape. And only violent collisions between celestial bodies seemed to hide the answer. Oumuamua, if it were an asteroid, had to be born in a war. In a battle among the children of a star who fought to dominate gravity. After all, the asteroids in our solar system are the debris of an ancient era of destruction. Rock debris left void, drifting through space, at the mercy of the sun for all eternity. It was evident that this process would have repeated in all star systems in the universe. But that as a result of a collision, a body with such a strange shape could emerge, not seen in any asteroid in our solar system, was a mystery that could only be solved in one place. NASA's Ames Vertical Gun Range is a facility that simulates the physics and mechanics of planetary collisions, capable of recreating impacts at speeds of up to 7 kilometers per second. The complex conducted tests to simulate what would happen when a smaller body collides with a larger one, such as a planet, at various angles. And finally, at a very precise angle, an angle so specific that in space it would be a matter of a few kilometers, they found that the collision generated fragments with a size ratio very similar to Oumuamua. Its birth was mathematically possible. However, this discovery raised doubts again. Estimates indicated that Oumuamua would have been wandering in space for about 100 million years. Assuming that such a thin asteroid survived not only the chaos of the formation age of its sun without any other object colliding with it, but also the journey through interstellar space, was an enormous act of faith. The survival of this hypothetical asteroid was so improbable that again they could not guarantee the resolution of the mystery of its nature. The days passed, and the doubts remained. It couldn't be a comet because there was no tail, and they couldn't be sure it was an asteroid. And in the midst of this uncertain situation, a new enigma emerged from the darkness.
Las reconstrucciones de su trayectoria mostraron que después de ser desviado por el Sol, Oumuamua experimentó una aceleración no gravitatoria. Algo normal en los cometas que al sublimar el hielo, el gas emerge y se forma una especie de jet propulsor que hace que gane velocidad. Oumuamua estaba acelerando de la misma forma, pero no había ni rastro de esos gases emanando.
Corroborating the measurements, understanding that the only explanation for that non-gravitational acceleration was the sublimation of ice and the consequent propulsion through gases, the nature of the visitor became clear. Oumuamua was a comet. The fact that we had not detected signs of gas, not observing the expected tail, had to be either because the emission was too small for the precision of the telescopes, or the jets were composed of particles that did not diffract visible light. Either way, confirming that it was a comet, it was time to detail its composition. Both alternatives to the invisibility of its tail were linked to a constitution that we had never observed in a comet in the solar system. So 2 weeks after its discovery, they reached the final stretch. The last opportunity to decipher its mysteries. Astronomers from around the world join forces in that Odyssey as news about a visitor from the stars begins to spread beyond the world of science. Oumuamua quickly becomes a phenomenon, awaiting the true news that would make everything explode.
Un visitante del medio interestelar navegando por primera vez cerca de la Tierra, con una forma nunca antes vista en ningún cuerpo celeste, y por si esto fuera poco, ahora también con una propulsión que lo hacía acelerar por el espacio. Oumuamua lo tenía todo para que la palabra alienígenas empezara a sonar, y evidentemente, así fue.
Everything around Oumuamua was so seemingly unnatural that many were inspired by a hypothetical artificial origin. That body that had visited us suspiciously resembled an alien spacecraft designed for interstellar travel, with an elongated shape to reduce friction with the gases in that space between the stars. As its discovery and investigations transcended the media border, UFO enthusiasts relied on dubious reports from dubious witnesses who took dubious, unmanipulated photographs of cigar-shaped UFOs, claiming that there could be a connection. That an extraterrestrial civilization had built ships with that shape, and even in a display of their technological capabilities, hollowed out an asteroid to travel inside it. And although all these ideas originated from internet forums, there was one person who gave wings to the alien origin of Oumuamua. The American theoretical physicist Avi Loeb took the idea seriously and claimed that the brightness variations were also consistent if they assumed it was a large solar sail, a theoretical space technology in which a ship would be propelled using solar radiation as thrust, like the sails of a ship, but with the sunlight instead of the wind. Loeb argued that it couldn't be a coincidence that the orbit had taken it between the Earth and Mars, precisely the habitable zone of the solar system. Oumuamua had to be a ship patrolling the galaxy in search of other forms of intelligent life. And despite the controversies that had always surrounded him, he was able to use his influence for the Green Bank Telescope in Virginia, the world's largest steerable radio telescope, to point towards it and reveal the most important discovery in human history: the existence of an alien civilization visiting us. Deducing that if it were a ship, it would have to be equipped with communication systems, and among all the forms, radio waves would be what an interstellar civilization used. The search for those echoes of its existence began. Aware that at any moment they could come across signals of extraterrestrial technology, the radio telescope listened to that object. And after 8 hours of data collection, the results finally arrived. Absolute silence. There was nothing. Not the slightest radio signal. As expected, Oumuamua was part of nature. A comet that crossed the path of the sun's gravity, and by the whims of chance, we caught in the firmament. However, despite proving the invalidity of the alien theory, when news of Loeb's research reached the press, a media storm was unleashed. Media outlets worldwide, due to understandable misinformation, began to talk about Oumuamua as a possible extraterrestrial ship. The mysteries around what the community already knew was a comet made it a global phenomenon. For days, while the race against time on Earth continued and it moved out of our reach, Oumuamua reached worldwide fame.
En ese momento, cuando las noticias de Oumuamua inundaron las redes y la prensa, los esfuerzos del equipo se centraron en captar lo único que en esos pocos días que les quedaban podía darles respuestas: su color, porque con él podrían predecir una probable composición y terminar de encajar todas las piezas.
And combining various images obtained from both the Gemini Observatory and other telescopes around the world, they finally managed to get that clue. Oumuamua was bathed in a reddish color, a hue that had been observed before in other comets, confirming the icy nature of that body. It was clear that Oumuamua was a comet, probably composed of frozen nitrogen. But with this certainty on the table, they had to explain why it was not behaving like one. The reason for not forming a tail when passing close to the sun. For sailing like a lifeless entity. Knowing that they could no longer find more answers in the sky, hope was placed in NASA's Cosmic Ice Laboratory, the facility that studies the chemistry of ice in the universe, the properties of comets and icy worlds. The scientists at the laboratory considered that the lack of a tail, the non-emission of gases, could be precisely due to the thickness of Oumuamua's ice, much greater than that of comets sailing in our empire. And it was all due to that journey through interstellar space. they had developed hundreds of experiments on the effect of cosmic radiation on the outer layers of comets. Their composition, the nature of the chemical elements on their surface, is altered after intense and prolonged exposure. Both ultraviolet radiation and cosmic rays, when their energy hits molecules such as nitrogen or methane, cause dissociation and ionization, triggering a chain reaction in which carbon atoms rearrange to form more complex molecules. Polymerization leads to the formation of a tholin aerosol, the substances that ultimately precipitate onto the surface and are responsible for that red color. Hence, most comets have a slightly reddish coating. But in the specific case of Oumuamua, this process would have been much more intense. It has spent tens of millions of years in interstellar space, without the protection of the magnetic field of any star. Therefore, in that eternal journey, it has been much more exposed to the invisible threats of the cosmos. Oumuamua has been bombarded by the fury of cosmic rays, high-energy particles accelerated in the most violent events of the universe to speeds practically equal to that of light. A cosmic shrapnel, cosmic bullets that pierce the oceans of darkness, massacring any bodies that cross their path. The formation of tholins in Oumuamua could have been accelerated so much that in those millions of years, a reddish armor of approximately half a meter thick could have formed, protecting the ice at its core, preventing even the heat of a star from tormenting it. The tholin armor explained why Oumuamua did not form a tail despite being so close to the sun. The ice is retained under it, and the emission of gases is minimal, only to allow that non-gravitational acceleration they had perceived in its trajectory. Everything fit. The nature of the interstellar visitor had been deciphered at the last moment. A few days later, Oumuamua escaped from the reach of our telescopes. The visit was over. That gift from the stars had faded into the eternal darkness of space, never to return, to continue its journey through the oceans of darkness. A new chapter in a story that we had time to read.
La teoría de la formación de tolinas en su superficie no solo permitió descifrar su evolución. Se cree que estos compuestos orgánicos en presencia de agua podrían funcionar como la materia prima para la química prebiótica. Las tolinas podrían ser los bloques fundamentales para la vida, y con ello una increíble posibilidad se abría ante nosotros.
Sometime after Oumuamua vanished into the cosmic horizon, spectral data analysis revealed the presence of what was most likely water. This finding, although unconfirmed, made that visitor much more interesting. The presence of water and tholins, created by the bombardment of cosmic rays, turned Oumuamua into a messenger of life's fundamental building blocks. A potential carrier of prebiotic chemistry that in the right places could make the most important aspects of the universe flourish. Suddenly, we realized that comets like him could be spreading the pillars of life across the cosmos, allowing these ingredients to be shared among the stars. Like gifts from the gods of light, scattering across the seas of darkness. Oumuamua was teaching us that perhaps it was interstellar comets that brought the seed of life to our once inert world. If, by the whims of capricious gravity, one of these messengers collided with Earth, prebiotic elements could have spread across the young Earth. A gift from a distant star that, after millions of years wandering in the darkness, found in our planet a place to bring meaning to the cosmos. After all that waiting, the seed of life could flourish. Those visitors had brought the message to us. And by somehow hiding the legacy of another star today, it is concealed somewhere in the night sky.
Oumuamua abrió la puerta a la teoría de que fueron los cometas interestelares los que plantaron la semilla de la vida en la Tierra, pero por muy poética que fuera la idea, solo había una forma de probar la hipótesis: viajar hasta un cuerpo como él y tomar muestras de su superficie, asentarnos en un mensajero interestelar.
Under this pretext, NASA began working on a project that could one day culminate in one of the great achievements in the history of space exploration. The main idea is that Oumuamua was not the first messenger from another star to visit us, simply the first one that by sheer chance we were able to detect. In fact, simulations recreating the expulsion of similar bodies in the thousands of nearby star systems showed that at least about 10,000 objects like Oumuamua should be in our empire, within the orbit of Neptune. We haven't seen them. They've gone unnoticed. But we are sharing our home with many interstellar messengers. Today, as demonstrated by the Rosetta mission, which intercepted and landed on the surface of a comet in 2014, space agencies have the technology to develop a probe that travels to these bodies, collects samples, and even returns to Earth with them for further analysis. The problem with this ambition is not technical. The major impediment is time. Planning the entire mission and eventually sending the probe into space to later intercept the orbit of the body is a process that takes years. Oumuamua appeared suddenly, and within weeks, it was out of our reach. Interstellar messengers arrive without warning, at speeds so high that before we realize it, they have disappeared into the shadows of space. If we want to fulfill that dream, it all depends on much earlier detection. Thus, all hopes are currently focused on the Vera Rubin Observatory, which is expected to be operational in 2025, a telescope being built on Cerro Pachón in northern Chile. With its 8.4-meter primary mirror, it will be able to photograph the sky with unprecedented clarity, with an estimated sensitivity 14 times greater than that of Pan-STARRS, the discoverer of Oumuamua. We may be able to detect many more interstellar messengers and perhaps, just perhaps, seize the opportunity to forever rewrite the history of astronomy.
Ese mismo mes de noviembre de 2017, Oumuamua dejó de estar al alcance de nuestros telescopios y se prevé que abandonará el sistema solar en unos 20.000 años, para regresar al medio interestelar. Pero en esas pocas semanas que pudimos verlo, se convirtió en el precursor de una nueva era. Gracias a él ahora soñamos con hacer algo que hasta ese momento parecía imposible.
Oumuamua inspired us to break the boundaries of the solar empire, to gaze into the heavens seeking that opportunity to fulfill the greatest ambition in the history of humanity, to make contact with a messenger from the stars, to understand the most elemental origin of life, to have a part of humanity reach out to the child of another sun,